What we want to do with this one now is we want to start talking in terms of what I've just been calling a hybrid system, where we mix different data together and use the site calibration to kind of bring it all together for us. Let's just expand this out a little bit and let's talk about what we want to do. So we want to use GPS or GNSS out in the field. How do we do that? Well, the first thing we have to do is go into the survey information, and in our coordinate reference system we have to tell it where we are. So we're going to pick NED 83, the 2011 epoch. We're in California 2, so California 2 zone, that's where this user was. And then we're going to go into the project factors and we're going to leave this grid bearing and grid distance. Do you remember in the March discussion when we came in and looked at the different options in here? We said we've got this one called hybrid. I just want to look at the drawings. And we're really thinking in terms of I can work with a state plane grid and I can bring it up here. Okay, so maybe I shouldn't be calling this one hybrid, because really I'm still just working with local. Okay, but I'm going to be using the ellipse and the projection just like I did in that hybrid that we talked about, even though I'm at 5,000, 5,000, not state plane. So I'm going to be working in grid bearing and distance. I'm going to be working on a state plane grid. So now I have a way to compute geodetic to projection coordinates, or in this case state plane coordinates. So this user went out and imported GPS data. So they went File, Import. In the ASCII settings, they said I'm going to bring in point, latitude, longitude, and description with a CSV extension. We're going to generate details for that so we can see what it did and add those points to a traverse. Here's the file we brought in, and if we just preview that real quick, it'll open up Excel because it's a CSV, and on my computer that's the default program to open that. Let me just make sure this is big enough here. But can you see that point 11 has got a latitude, a longitude, and a description. So whether this was RTK or post-process, it really wouldn't matter. Out of that GPS or GNSS system, we just exported the geodetic positions that we collected in the field. Now, this is important. I can do this in the field, or I can come back and do this in the office. Point 16, which is a geodetic point, we said is the same as point 1 in our local survey. And we used a #1 space to identify that. We did the same with 17, which equals our point 3. We did the same with 4, and we did the same with 2. So we've got 4 points here that either in the field or back in the office, we've identified this GPS point is the same as that local point. And I'm going to show you why we did that here in just a moment. So we go ahead and import this into our survey. And here's what I got when I imported that just a little bit ago. I converted my decimal degrees to degrees, minutes, and seconds. Here are my descriptions that came in with those same pound here. And now if I open up this traverse that it created, I'm going to see, and let me go ahead and just turn something off here real quick. I'm going to see that here are my state plane coordinates generated from those geodetic positions based on my coordinate reference system. Now, if I were to plot these up, they're going to be plotted up in state plane coordinates. So my coordinates in this drawing are going to be, millions and millions in the x and y, because that's what the state plane coordinate projection produces at this geodetic location. And then, of course, here are my geodetic points. Now, I'm going to use this formatting in here to identify what I'm really working with. And I've told it that I want geodetic points to be this royal blue and italics. So that's why it's drawing them that way. You're going to see in a minute I've told it calibrated points. I want those underlined with normal fonts. So just a way to kind of identify what's in here. Now, of course, you know that if I were to go ahead and plot this, I would end up with a dot at 5,000, 5,000, and I'd end up with a dot at the state plane positions. But watch what we're going to do. I'm going to go ahead and tag this just so you see this as soon as we are ready to roll on it. We're going to come in and create a calibration to go ahead and reconcile those GPS or GNSS positions with our local survey. So right now, before I calibrate, I've got geodetic positions, I've got state plane coordinates, and I've got local coordinates all in the same survey. And the problem is they just don't match. So I'm going to create a calibration then, and we're going to reduce that to geodetic positions and local grid coordinates. And the way I generate this calibration is really easy. I just say, I've already got a traverse where I've used some character, in this case a pound, but you could use whatever character you want. I've used some character in the description to relate the points. So I'm going to select that traverse, Southline CSV, and I'm going to tell Traverse PC, go ahead and generate a calibration for that. And let's just look at the information we got here. So here's my rotation. I'm doing a 2D conformal. So that means the relationship between points X and Y hasn't changed. If there was some distance between those points to begin with, that's gotten factored, but so have all the other distances. So if one distance is twice a distance, after the calibration, it's still going to be twice the distance. So that's what conformal does for us. And I'm looking here seeing I've got very little scaling. I've got just a slight rotation, so it's kind of what I expected. And then I've got this large translation. And I can come in and look at the points, and here's that point again that identifies that 14 is the same as my local 2. So here's my 14 state plane position. It's the same as 2, which is my local position. And of course I've got this huge translation difference between it. And I've got 4 point pairs like that I'm using to generate the calibration. And then I've got these uncalibrated points that are also going to be calibrated based on whatever calibration I generate here. And then I'm just going to come in and tell it, okay, let's save it as Southline CSV. I'm going to tell it, here's the survey that generated that calibration. This is just some record keeping for me, so I've got some notes. I'm going to tell it I'm going from NAD 83 California GRS 80, and I'm going to go to a local site. And this is just some reference for me that kind of helps me keep track of what I'm doing here. I've saved this earlier, so I'll go ahead and overwrite that. So I've now created a calibration file that relates those GPS points to my local survey. And all I have to do is go into my Site Calibration tab for the survey and say, apply this calibration, and I can reload it here and say, this is the one I want to use. It's the one I just created. Apply that to geodetic points. And as soon as I do, here's my GPS points, no longer plotted at state plane coordinates, instead plotted at my local site. And in fact, you can see I'm lining up with my record points in those GPS points at all these corners. Exactly what I want. So now my features are in the right place, my boundary is picked up properly, and I've now reduced this survey to geodetic positions and local site coordinates. Let's take a look then at what happened to this traverse. We had this open just a moment ago, and we can see that, remember I formatted these to underline anything that's been calibrated. So all these points now have been calibrated, and instead of seeing the state plane coordinates, I'm seeing the local site coordinates. In fact, if I went into any one of these points, and I'll use one that got calibrated, and we say modify points, point properties, I'm seeing the coordinates for that point, and these are the calibrated. I could also say, show me the uncalibrated. Here's the state plane positions. Okay, but I'm using this Southline CSV calibration. There we go. And here are the calibrated positions. So these are my local site coordinates for that point. So now let's talk about some workflows. I've got this set up the way I want, and let's talk about what I might want to do next with this. So let's say I'm going out tomorrow and I'm collecting more site data. I kind of got this much done while I was out there today, and I wanted to make sure I came back and everything matches up. Now I'm going to go out and gather more data. What do? Well, I go out and get the data. Tomorrow I come back and I import, just like I did. I import ASCII. I bring in the same information in a CSV file. Traverse BC imports it. It adds another traverse to my traverse manager, and sometimes I'll come in and put the dates on these so I know what date I brought those in, or go in and make some notes in the properties and say, you know, this is my preliminary stuff. I went out today and picked up some septic drain fields, or you know, whatever I was picking up that day, and make some notes about that. But now these points are going to be plotted where they belong over the local survey, or local site survey, because of site calibration. So all geodetic positions, regardless of whether I collected them yesterday or today or a week from now, are all going to be calibrated to local site automatically. So it's like I never have to think about that again. It just kind of happens for me.